assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So this problem gives us the reaction 2 SO2 gas plus O2 gas reversibly forms 2 SO3 gas and gives us a Kp of 0.355 at 950 Kelvin. And so the first thing we want to do is, since they give us the number of moles of our reactants, we want to find the pressures of our reactants. And so in this case, P of SO2 is equal to P of O2, and that's because they have the same number of moles, which is the equation here is the ideal gas law, nRT over V. And so we have 0.100 moles times our gas constant, 0.0821, times our 950 Kelvin, over our 2.75 liter volume. And that gives us a 2.84 atmosphere partial pressure for the two of those. So now we can move into an ice table, initial change equilibrium. So we have the P of SO2, the P of O2, and the P of SO3. And we have initial change equilibrium. And so here we have 2.84, here we have 2.84, and here we have 0. We are losing 2x of this, losing x of this, and gaining 2x of this. And that is due to our molar ratios. And so we end up with equilibrium concentrations as follows: 2.48 minus 2x, 2.48 minus x, and 2x. And so now we can plug that into our Kp equation. So we have Kp, which is equal to the P of SO3 squared over the P of SO2 squared times the P of O2. And that equals 0.355. And then our P of SO3 is 2x. Our P of SO2 is 2.84 minus 2x, and we have to square that. And our P of O2 is 2.84 minus x. And so now we want to solve this equation for x. And when we do that, we get an x of 0.66422. And so now that we have our x, we can solve for our partial pressures of our products and reactants and then add them up to get the total pressure. So P of SO2 was 2.84 minus 2x, and our x was 0.66422. And so that equals 1.51156 atmospheres. Our P of O2 is 2.84 minus x, so 0.66422. And that equals 2.17578 atmospheres. And our P of SO3 is equal to 2x, so 2 times 0.66422, which is equal to 1.32844 atmospheres. And so now our P total is the addition of PSO2 plus PO2 plus PSO3. And so we have our values here. We can just plug those in. And when we solve for that, we get a pressure of 5.02 atmospheres. And so that is the total pressure of the system at equilibrium.